All right, welcome. This is your lesson 3 notes for Unit 7, Proving Triangles Similar. Um, quick note, I added an extra question to the first one. It says, how do we determine if shapes are similar? So this is review of last unit. Remember, we have to say that all corresponding angles are congruent. So any angles that are in the same position have to be exactly equal. And then all corresponding sides have to be proportional, or the ratio of their sides have to be proportional. So if we go back to the question, how do we determine if the side lengths of the two shapes are proportional? Give you an example. Let's take 2. Let's take 3 over 4 and 6 over 8. So if these were two side lengths from any shape, to decide if they're proportional, or if they're ratios, this is one ratio, this is the second ratio, are proportional. There's a couple ways we can do that. The easiest way is just divide 3 divided by 4. Okay, and if I do that, I get 0.75. Okay, now for this second fraction, I should get 0.75 when I divide them. Well, 6 divided by 8 is also 0.75. So that's kind of the easiest way, I think. The other way is to cross multiply. 3 times 8 is 24, and 4 times 6 is 24. So because both of those numbers were 24, they're proportional. And the final way is to reduce all of your fractions. 3/4 is already reduced, but if we divide the top and the bottom of this fraction by 2, that would reduce down to 3/4 also. And because these two are equal to each other, the sides must be proportional. This is also called the similarity ratio. Okay, when we take the lowest form, or when we reduce or simplify the fraction to the lowest form and get 3/4, that would be our similarity ratio. All right, so this can be a lot of work. You can have, if it's a triangle, you can have 3 angles and 3 ratios, or 3 sets of proportions to prove they're proportional. That's a lot of work, so we're going to show you some shortcuts. There are a few ways that you can take a shortcut. It's like going to the store but cutting through your neighbor's backyard. It takes us less time. We can get there, but the result's the same. We can still get to the store. So one is SSS, and these 3 S's here stand for side, side, side. Okay. The reason it's just sides, it's all 3 sides in a triangle. By the way, I forgot to point this out. The rest of this lesson is all going to be about triangles. So the 3 sides of the triangle then have to be, just like number 2, all corresponding sides are proportional. So we're going to ignore the angles totally. We don't have to prove anything about the angles, and we will find out if they're similar. If they are similar because all 3 sides are proportional, then all of the angles are also congruent. So the corresponding sides of 2 triangles are proportional, then the triangles are similar triangles. Okay, so let's look down to this shape. It's an example of using side, side, side. So we're going to see if we can make sure this works with side, side, side. So let's look at the sides. Ignore angles totally at this point, because we can use our shortcut of side, side, side to only do 3 things instead of 6. And I'm going to start doing small over big. I'm going to set up some ratios. They should all be proportional. So I'm going to have 3 ratios here. I'm going to start with the most obvious side. I'm going to take this 9, that's my small, and the side it corresponds with, or if I highlight it with the 9, is the 12. Okay, so the 9 goes with the 12. And because this 9 goes with 12, what you can tell is this has kind of been spun around if we were to match it up. So what that shows us, we'll use our Darth Vader pen. Okay, I wish I had some good sound effects for that, but side AC here, if I spin this around and put C on top, would match up to side GF. Okay, so I'm going to do 6 small over 8, and the remainder, the side that's not highlighted, we'll do 6 over 8. Okay, when we reduce all of these down? Okay, so I'm going to do the reducing method. We divide this by 3 and divide by 3 to reduce the fraction down. I get 3/4. This one, if I divide the top and bottom by 2, it will reduce down to 3/4. And obviously, if that was 3/4, this must be 3/4. So because all of these ratios are the same, they all reduce down to 3/4. All these sides are proportional. So these are for sure similar figures. Now, what that tells us is, back to number 1 up top, is that all corresponding angles are congruent then. If these are similar figures, then all corresponding angles have to be congruent. So that's going to help me get this angle. Let's finish off this line here. So the reason is side, side, side. That was our shortcut. Triangle, I'm going to do triangle ABC. Okay. Now look at where the red and the yellow meet, that's A. So I'm going to find where the red and the yellow meet over here, that's F. Okay, and then I'm going to go across the yellow to B and across the yellow to E. Then obviously C goes with G. So E, G. Order matters. Okay, now to solve for X. What you need to notice about this is a review from the last unit. This is an isosceles triangle. We have two sides that are equal, so I'm going to mark these sides equal, but that tells us something about the angles. If I go across from the equal sides, these two angles would also be equal. So to get one of these, what I have to do is I do 180 degrees total on a triangle, and I take out the 100 for this angle G. That leaves me with 80 degrees left for these two angles. Because these two angles are equal, I want to divide the 80 by 2, and that gives me 40 degrees each. Now if I go back up to my statement here, the question is angle X, and angle X is where, or X degrees is where angle A is, and angle A goes with angle F. They're in the same position. So angle F is 40 degrees, angle A must also be 40 degrees. One shortcut down, on to the next one. So maybe you'll be able to figure out this one. This S and this stands for side. A stands for angle. And the S stands for side. So we have side, angle, side. So it states if an angle of one triangle is congruent to an angle of another triangle and the sides that create the angle, so create this angle that's the equal, are proportional, then the triangles must be similar. Another shortcut to Grandma's house. Or the store, I think I said earlier. But now, the thing that tricks kids with side, angle, side is they want to pick any sides. And notice it says it's got to be the angle that's between the sides. So it's side, angle is right between. So if I look here, my 90-degree angle, my two 90-degree angles are the ones that are equal to each other. QR corresponds to XY, okay? And then PR corresponds to XY. And I picked those ones because those are the two sides that make that angle. For side, angle, side to work, it's got to be side, angle, side. I like to label them so I know side, angle, side. And the angle's got to be right between the two sides. So we got to check. Okay, that's 90, that's 90. So it looks like angle R is congruent to angle Y. So that covers the A in our side, angle, side. So we kind of got to check. We got an equal angle. Let's do our two sides. So I'm going to go small over big, 3 over 4, and then 6 over 8. And those should reduce down to the same proportion. If you look, 3/4 is fully reduced. Divide the top and bottom by 2 again, I get 3/4 here. So I get 3/4 is equal to 3/4. The sides are proportional, or at least the two sides we had to prove. So this is two similar triangles. The reason would be side, angle, side. Triangle, now let's go in order. I'm going to go from Q to the 90, which is the R to the P. QRP. So I got to go in the same order. X to the 90, which is Y. And then Y to Z. X, Y, Z. If you don't put them in the right order, they will not be marked correctly. Now that we know that these are similar figures, we know all the angles are equal, and we know for sure all the sides are equal. So to solve for x here, we're going to have to set up a proportion. We already know what the similarity ratio is. It's 3 over 4, so I'm going to use that 3 over 4. I'm going to set it equal to, remember that was small over big, to 6.7, because that's the small side on the triangle, or the small triangle. 6.7 over the big triangle is x. Okay, then I'm going to cross multiply that, and I get 3x equals 4 times 6.7, which is 26.8. And divide both sides by 3 to get x by itself. I get x equals, we'll say, about 8.9. Okay. And what's the difference between a congruency statement and a similarity statement? A congruency statement would be like if we said, let me give you an example of that with these two triangles. Now these two triangles are not congruent. They're not exactly equal. Maybe I'll draw two equal triangles here and call it triangle ABC. My beautiful triangles. And triangle EFG is, if I want to say they're congruent, all the angles and sides are all exactly the same. A similarity statement says all the angles are the same, just like if they're congruent. But all the sides are proportional, not equal to each other. So this would be like ABC is congruent to EFG, where the similarity statement up here is what we wrote right here. This QRP is similar to XYZ. These are completely identical. This one's smaller, this one's bigger, but the angles are the same. All right. I'm going to get the last one in before my time runs out. I got 2.5 minutes. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. This is our last similarity, or our last shortcut. It's angle, angle. And notice there's a third angle in the triangle because whenever you know two, you know the third. So if we look at this, I got one tick mark here, one tick mark. Oops, let me move this over. And then I got two tick marks and two tick marks. I have two angles that are equal. And whenever I have two angles that are equal, the triangles are congruent to each other. So ABC is similar to triangle DEF by angle, angle. Okay? Now we're going to use the angle, angle postulate. Notice it says JK is parallel to MN. So I know this side is parallel to that side. This is what angles are congruent and why. Well, right here, if we look on both sides of L, the angle JLK and angle MLN, those are congruent because they're vertical angles. So JLK, angle JLK is congruent to angle MLN. And that's because they are vertical. Now, because this is a parallel line here and a parallel line here, and notice I have a transversal cutting across, well, let's say right there. If I have that, this angle here would be equal to this angle here. Okay, and those two angles are equal because they are alternate interior angles here, parallel lines and transversal. So I'm going to say angle K and angle M. Angle K is congruent to angle M. That's because of AIA. So now we have two angles in each triangle congruent. So JKL is congruent to NML by angle,